All right. We are talking today about the polar coordinate system. All right back here. Some people have asked me when they come in here, like, what is that circle thing? It looks kind of like the unit circle on your board. This is called a polar coordinate plane. All right, we're going to talk about what that is and how to use it. Again, we are not going as in-depth as the other pre-calc class. You guys aren't going from here to calculus. So we're just kind of laying the foundation for the next math class that you are going to take. Some of you probably won't see this again. Some of you will. So just take in what I'm giving you. You've got a test on it next week. We got to get through it, seniors. Underclassmen, you're stuck with me longer. But when we talk about plotting points and stuff, you guys are super familiar with X and Y. Right? We have a directed distance, meaning I have an XY plane, XY coordinate. This is my x-axis. This is the y. If I give you this point right here, over 2, up 3, whatever, it's in the first quadrant, right? You guys are super aware of that. This is on the rectangular. You guys have seen this before when we were talking about yesterday eliminating t with our eliminate the parameter. Then you wrote your equations as a rectangular set of the rectangular, what am I trying to say? Like a rectangular plane sort of thing. All right. You are going to use the thought process of going left and right and up and down and all that stuff, negative angles, positive angles, very similarly to that you've done on your XY, but now we're going to use it using the polar coordinate system. God bless you. This is what your polar coordinate system looks like. What is it? What when you first see this, what do you see? Center. Okay, I see the center. Good. What do we call the center on our XY coordinate? 0, 0. What do we call that? Because, okay, origin. All right, we have something very similar. We're going to talk about that in a minute. What else do you notice about this beautiful drawing? It does look like the unit circle a little bit, right? I have 0. Up here is pi over 2. That's our 90 degrees. Over here is pi. Down here's our 3 pi over 2, right? Here's our 30, 60, 90s right here. 45, 45, 90s. Everybody see that, all right? So we're going to be using our polar coordinate system. A lot of things you guys are going to be familiar with. We're just using different vocabulary for right now. Everybody with me? Okay, stay with me. This point right here. This point right here is our origin, like we just said. But we don't call it the origin. In the polar coordinate system, we call this the pole. All right, so this is the pole, not the origin. But it's similarly, you can equate it to that as you're thinking about this. So right here in the middle, this is our pole. Right? We're good? Now I have this piece right here. Now when we were graphing, when we had our angles, this was our initial side on the x-axis, correct? It's where we started. Initial means where you start. Well, in our polar coordinate system, it's called the polar axis. But it's the beginning. It's where we start. It's right here at 0. It's your initial side where you start counting from, however you want to look at it. But it is called the polar axis. Now, if I have an angle measure and I'm going to draw the angle, if I start from the polar axis and I go up, what kind of an angle am I talking about, you think? Positive. Good. Very good. We've talked about that before. What about if I'm given an angle and I go downwards? It's negative. Okay, good. Very good. Now, generally, when you guys are asked to plot a point, you get an x and y coordinate. In our polar coordinate system, we're going to get an r value, comma, and angle. If I were to draw a line right here, does this triangle look familiar to you guys? Okay, what kind of a triangle does that look like? 90 a 90 degree, right? Okay, so this would be my x value, this is my y value. What is this called? We were doing all of our trig functions. Our hypotenuse. What letter did we use? R. Look at this, guys. Right? Huh, so funny. It all comes together now. All right, this is going to be a directed distance. All this is going to come together in a minute. All right, this is an angle measure. We're going to plot points today, and we're going to understand how we can find the exact same point represented with different numbers a different way. All right, we okay so far? All right, I have another question, just to bring you guys back to the unit circle and that sort of thing. Say I'm right here at pi over 6. Do you guys remember that if I added 2 pi. What happens if I was at this point and I added 2 pi? I go all the way around the circle, and then what? I end up where? At the same spot, right? Could I add another circle and end up at the same spot? Yes. Are those the exact same points? Yes. Are they the same values? No. The numbers are different, right? Remember we add and subtract 360 or 2 pi. Does anybody remember what that's called when you add and subtract a whole circle? Chapter 4. Seems like ages ago. Coterminal. Good. Okay, good. All right, this is basically the same thing we just talked about, just in words. Some of us like words a little better. Now, I want to talk to you about how to plot what you're looking at. We're going to just take a second to bring all this stuff together. Now, if I said to you, plot this on the XY coordinate grid, I have the point 2, 5. You guys agree I'd go over 2, 2, 4, 5, up 5, and there's my point P, yeah? Can I represent that point P with different numbers? Can I multiply each piece of my coordinate by a number and get the exact same spot? Can I add this? Can I do anything to represent that point P any other way? No, right? If I add something to X, that moves the point to a different location, right? So in your rectangular coordinate system, you have a unique, whoops. You guys know what I mean. You have a unique, you have a unique spot for this one point. I can't just add 12 and come back to the same spot. I can't subtract 9. I can't multiply. It's a unique description right there. Our unit circle is a little different, and our polar coordinate's a little different. Say I have this point here. I'm going to tell you guys right now. All right, go ahead. Graph 2, comma, pi over 3. Go ahead and do it. Go. Anybody? Okay, no worries. Let's go. We're going to do it right now. I don't expect you to know how to do this. I mean, some of you might have seen this last year, but I don't expect you to do it. What I want you to understand, this number right here, is the units away from the origin or from the pole, Somebody in Miss Carver's class said, count the rings. You'll see what I mean by that in a second. This value here is the angle. So, let's go back to what I just asked you to do, is plot this. Where do you think we should start? At the origin. What do we call the origin in our polar coordinate? The pole. Start at the pole. Right? All right, now how in the world do I even begin? Well, think about this. If we were going to just draw an angle, I would start right here on the initial side, the x-axis. We don't call it that in our polar coordinate. What do we call it? It's the what axis? Polar axis. The what? Polar? Is that what you said? Oh, yeah. You just say yeah, go with yeah. Yeah, polar. Good job, Gene. Polar axis. That's where we start. So I am going to find the angle that they're telling me to find. What angle do they want me to go find? What is it? Pi over 3. So let's go to positive. I'm glad you said that, Victoria. Positive pi over 3. So it's right here. So everybody see that? That's where we're talking about. Now, you have found the angle that they are talking about. Now we're going to figure out how far away from the pole we're going to move. Each one of these intersections, like here, these little arcs, here, 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 those are your intersections that you count. Somebody earlier, like I said, that's how many rings away. So from the center, how many rings are we going to move? 2. It's a positive 2. There's going to be a difference between positive and negative. If it's a positive number, you're moving towards the angle. So I'm going to go from the center. I'm going to go 1, 2, and there's my point P right there.
Wait, how did you do that?
I started from the center, and then I looked at this number right here. It says, hey, it's 2 positive. So you're going to go towards the angle that they're talking about. Now, 3 minutes ago, if I gave you a point and said, here, graph this, you guys were like, what? Now it's like, oh, okay, I find the angle first, and then I count. All right, it's not terribly difficult. It's just super different from what you guys are used to seeing. Yes, sir.
Does it always start at like 0?
Yep, always. Just like when you graph an XY, you always start at the origin, right? Same thing. So now we're going to look at this, and this is where, yes?
So it can't be greater than 7?
Can't be,
Because it's only like 7.
yeah, you're not going to get that, yeah. Now, here's where, this is fun. If you watch Miss Boyd's video, I would actually laugh. She's like, this is the coolest part ever. Is that the only way to name point P?
No.
No. What are some other ways? Before I tell you, what are some other ways?
X, Y.
Well, okay, so I'm right here at pi over 3. Can you only go around the circle one time? No. Could I go around 14 times?
Yeah.
Right. Could I go backwards?
Yeah.
Okay, so let's think about this. If you want to plot the point, let's say 2, 7 pi over 3. So first thing we do is look for what? 7 pi over 3. So I look on the unit, not my unit, sorry, my polar coordinate. Where is 7 pi over 3? I don't see it. Nowhere to be seen. Why is it nowhere to be seen? Think for a second. Why is 7 pi over 3 not on here? Because it's what? More than 2 pi. How did Victoria know that? First of all, she said, well, 3 goes into 7 how many times? 2 whole times, with how much left over? 1/3. So would you guys agree if I started here at my polar axis and I went 1 whole time around and then I went 1/3, would I end up at the same spot? Yeah, I'm on the same pole, right? I'm on the same pole, and then I went out 2 spaces. Do you guys see that? It's just like our coterminal angle. If I said, okay, I'm at 60 degrees, and I want to find a positive coterminal, you guys would add 360. So 60 degrees would be the same as also what? 390, right? If I added another 360, do you see how you can represent the same point several different ways because everything is based on our circle? Does that make sense? Yeah. So when I tell you to plot this point right here, this is the exact same point, P. Because you would say, okay, well, where does that fall within our 0 to 2 pi? Well, it's bigger than 2 pi, so you guys, before we did this, you would have converted it to degrees, realized it was bigger, subtract 360, right? Same thing. What about if I said, okay, let's plot, what am I going to do? Let's do 2, negative 2 pi over 3. Right? What changed here? What's negative?
2 pi.
The angle that we're looking at. So how do we figure that out? Okay, we're back. All right. I need negative 2 pi over 3. Well, again, we're going to start right here on our polar axis. Start right here at the beginning, right? Whoops, too big. We start at the beginning. And how do you guys figure out where negative 2 pi over 3 is? You go backwards, okay? Some of us can do this really easily. Some of us, we still have to count. Hey, guess what? No shame in that game. Where is positive 2 pi over 3? I go 1, 2, 3, 4, 5, 6, 7, 8 spaces up, right? So if I want to find negative 2 pi over 3, I go 8 spaces where?
Down.
So 1, 2, 3, 4, 5, 6, 7, 8. I have this point right here. This angle. So I'm here. And then where does it tell me to go from the pole, from the origin? Towards it, right? So 2 rings. So I'm going to go out. 1, 1, 2. So here's this. We'll call this point Q. All right, you guys see that? All right, well, where was 2 pi over 3? It was 1, 2. Right here, correct? This was point P. All right, do we notice anything about P and Q? It's on the same line. How many spaces away from the pole, from the origin is it? 2. It's both 2, but what do you notice about the directions?
Opposite.
They're opposite. So what do you think the negative sign means? It is like the inverse. So if I gave you the coordinate -2 pi over 3. Is that going to land me at P or at Q? How come? Because you go to pi over 3. Good, perfect. Because you're going down. You're going away from.
So that's the same thing.
Yep. Yeah, we're going to talk about all the different ways that we can represent this point. If I come here,
Wow.
I know. And you thought you were done. Come on. Silly. I'm at pi over 3, right? So I go and I'm at the pole and I'm going to go, oh, pi, but I don't go towards pi over 3. It's telling me, ooh, negative, stay away. So I'm going to go which way? I'm going to go backwards and I end up right there. So what we're going to work on today, we're going to plot a few more of these points, and then we're going to talk about how you can represent the exact same point in a variety of ways. And it's really and truly, you can equate it to like finding coterminal angles. Remember when we added and subtracted whole circles to get back in the same spot? It's pretty much what we're doing. All right? Does that make sense? Okay, let's move along. That was a long time on that one slide. All right, here we go. So 10 minutes ago, if I said plot this, you guys would be like, now you're like, oh, so easy. How do you do this? What does the pi over 3 mean? That means, hey, find that place on our polar coordinate. So it's right here. And then what does the 2 mean? 2 away. I'm going to go to the pole. I'm going to go to the pole, and I'm going to go towards pi over 3 or away from it? I'm going to go towards it because it's positive. So we're at, well, right there. Questions? Anybody? All right. Good job. Good job. All right. Let's scoot along. Okay, we're done. Just kidding. All right. 3, comma, negative pi over 6. Okay, so let's get your mind right. Let's find our initial starting point. What do we call this initial starting point? What's the axis called? Polar axis. Somebody told me first period. Polar express. That's how I'm going to remember it. Fine. Start at the polar express. The polar axis. So my angle tells me where I'm looking to go. Where is negative pi over 6? If I go to positive, it's 2 up. So negative is going to be 2 down. So it's where? At 11 pi over 6. Perfect. And then it also tells me to do what? Go where? From the pole, I go where? 3 towards it. David, I need you to stop, please. I go 3 towards it. So 1, 2, 3. Right there. And there's your point. We're going to call it point David. Point D. Because he's super involved in paying attention to everything I'm doing right now. So this point, 3, comma, negative pi over 6, what's another way I could name it? 3, comma, what? 11 pi over 6. Perfect. Whoops. Very good, guys. What's another way I could name it? Hold on. Hold on. Let me highlight so we can see. It's another way I could name it. I could say negative 3, comma what? 5 pi over 6. Look at you guys. You see that? Yeah. All right. So let's talk about some. I'm going to just write a couple things down here. All right. What about if you had this? 0, comma, pi over 2. Where am I looking? Okay. I'm looking at pi over 2, right? But how far do I move from the pole? None. It's just at the pole. It's like at the origin here. What about if I said 0, comma, 4 pi over 3? It's still at the pole. What about if I said 0, comma, 147 pi over 2? Still where? At the pole. As long as your distance is 0, you're always going to be at the origin or the pole. Does that make sense?
What if your angle 0?
Yeah, it could be. That would just be where you would start. Hi. That would just be like on your polar axis. Thank you so much. Okay, let's look. Let's look at another one. What about if I said, okay, I want you guys to plot this point. I want you to plot negative 2, comma, 3 pi over 2. And again, this is so much easier to do when I'm on Notability. But I'm not, so I gotta keep erasing. How am I gonna plot this point? What do I look at first?
Oh, that it's greater
Okay, that's where can you find 3 pi over 2? Is 3 pi over 2 on your coordinate, your polar coordinate?
No.
It's not? Guys,
Oh, yes it is.
holy moly, right here.
Oh, never mind.
It's all good. It's okay. It's okay. It's the end of the year. I got it. All right, and then what is this telling me to do? -2. So am I going towards 3 pi over 2 or am I going away from 3 pi over 2? I'm going away. So 1, 2. So here's my point. We're going to call it point P. What's another way that I could name that point? 2 comma pi over 2. Perfect. Those are the exact same spots. You guys are so smart. Let's do another one. What about if I said, 5, and -5 pi over 6? Well, first of all, where is -5 pi over 6? We got to find out where the positive one is and then go backwards, right? Or some of you can just figure it out. That's fine. So positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to go 10 backwards. 1, 2, 3, 4, 5, 6, 8, 9. Whoop, where are we? 7 pi over 6. So now I see it's right here. I see 2 other ways that I can write this point. But I go, how many spaces do I go towards or away from? 5 towards. So 5 rings. Count the rings. 1, 2, 3, 4, 5. It's on that like darker looking one. What's another way I could name that point? 5. 7 pi over 6. Perfect. What's another way I could name that point, guys? -5 pi over 6. Perfect. You guys see that? Yeah. So whoever told you that was, oh my gosh, it was so hard. Don't listen to them. I tell you guys that all the time. All right, so by just plotting the points and looking what line they're attached to, the direction that you go from the pole, do you go towards the angle, away from the angle, you guys can name different points. There is a mathematical way to figure it out. This is what it is. And notice what changes in this mathematical equation. The R is positive here, the R is negative here. If you want your R value to stay the same, you add or subtract an even number of 2 pi, meaning 1 whole circle. If you want your R value to change from positive to negative or negative to positive, to be opposite, you're going to add or subtract an odd number of pi's. I meant to say odd number, even number of pi. It'll be 2 pi, 4 pi, 6 pi. Now understand what that is saying. Understand what that says. Is it -3? Whoops. Because you're going to be asked to represent points in other ways, which we've done. We've been doing that the whole way through here. But understand, guys, I want to show you why it's an even number, meaning 2 pi, or an odd number, meaning 1 pi. If I want to represent just this random point here, if I want to come back to the exact same spot, my R value here is what from the origin? 1, 2, 3, 4, 5. My R value is 5, right? If I want my R value to stay at 5, I have to go around 1 whole circle. You guys agree with me? So I'd have to add 1 whole circle to my angle. I'd have to add 1 whole 2 pi. If I want my value to go from positive over here to just use the -1, am I adding a whole circle? What am I adding? A half a circle. So I'm adding just 1 pi. So the reason that if you want it to stay the exact same number, you add 1 whole circle, you add an even number of pi's, meaning 2 pi, is because you want to end up back in the same spot. If you want to go to the opposite side of that line, you would only add half of that. Does that make sense?
Or 3, right?
Yeah, or you could go 3 times around or 5 times, you know, like, yep, any odd number. Good. All right, so in a question like this, we've done this kind of a question already 100 times. The only thing that's different, and this is the last thing I'm going to do, the only thing that's different is this little constraint here. And we'll talk about that in a second. But it says, find 3 additional polar representations. So 3 other ways to write this point. Well, let's write the point the way that it's given to us. -3 pi over 4. How do we do that? We'll find positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, right here. Do you guys agree? Okay, so where am I going from the origin? How many rings out?
3.
1, 2, 3. Here's the point. What's another way? We just plotted, guys, plotted the way I said it. We just plotted 3 comma negative 3 pi over 4. What's another way we could write that? 3 comma 5 pi over 4. Perfect. Now, just by looking, this is the line that we're on, right? What's another representation I can write? I could say negative 3 comma what? Pi over 4. You guys agree? Okay, perfect, good. So if I want an additional one, I'm not going to be able to just look at it. Can't just plot it. I'm going to have to add a circle or half a circle or something like that. So if I want to keep my R value positive, I want to keep it 3. That means to my initial 3 pi over 4, I have to add or subtract one whole circle, correct? If I add a whole circle to this, do you guys agree with me that 2 pi is the same as 8 pi over 4? So I'm going to add 8 pi over 4. This becomes 3 comma 5 pi over 4. Agreed? Did we already figure that one out? Yeah. Okay, so let's add another circle. If I add another 5 pi over 4 to that to find another representation, I end up with 13 pi over 4. Is that okay? That's fine. It makes sense mathematically, but what question? What part? I added another circle to that. I went around the circle another time. Now, why is that not okay given what they told us here? It's over 2 pi. So that one's not going to work. So if I add another, it's still not going to work. So let's subtract. Let's take 3 and our negative 3 pi over 4 and subtract 8 pi over 4. So I'm going to have 3 comma negative 11 pi over 4. That's a feasible option. That mathematically makes sense. But given the constraints that they gave me, that has to be between negative 2 pi and positive 2 pi, is this one going to work? How many times does 4 go into 11? 2 whole times with what? Some left over, right? So this is too small. That one's not going to work either. So we're not going to be able to keep our 3 positive for our last representation. We have this one here. We have this one here. We're going to have to do it where we keep the 3 negative. So if we keep the 3 negative, if we change the sign, guys, do we add 2 pi or do we add pi? Pi. If you are, because think about it, the direction that you move from the pole is opposite. So you're staying on that it's kind of like it's a half circle. So in this case, you would add and subtract what? Instead of 2 pi, just pi. So I'm going to take my initial, and it was negative 3 pi over 4. Okay, so negative 3 pi over 4. Let's add pi, which would be 4 pi over 4, right? 4 pi over 4, which gives me, I'd have negative 3 comma pi over 4, which we already found, correct? Right here? Just by looking. Right? So now I can say, okay, well, this is probably going to work. I'm going to take negative 3. Instead of adding the 3 pi, let's subtract it and see what happens. 3 pi over 4 minus 4 pi over 4. I get negative 3 comma negative 7 pi over 4. Is that one going to work? Why is that going to work? Is that smaller than negative 2 pi? No. It's close. Negative 2 pi would be negative 8 pi over 4, right? So it falls into the category. So by just adding 2 pi, subtracting 2 pi, just like our coterminal angles, you can add 100,000 times, you could subtract 100,000 times. This adds a little bit of a constraint to say, oh, wait, it's got to be in between negative 2 pi, positive 2 pi, negative 4 pi, positive 4 pi, whatever.
Is it always going to be in between those, or is it going to be different?
I'm not sure how we're going to do it, but we'll practice more. All right, that's it. That's all for today.